Alright guys, the 2018 MCAT worked solutions. Make sure you guys are doing these papers before you're watching these videos, because as you can see I'm really simplifying the problems and they're not going to make a lot of sense unless you've given them a good go. So question 1 is basically the sides of a rectangle are 2x plus 3 and x minus 2. So the short side is obviously x minus 2 and the long side is 2x plus 3. So the area is just base times height, and that's what we're wanting. We're wanting the area in the generalized form of that quadratic. 2x plus 3 multiplied by x minus 2. So expand this out. 2x times x, 2x squared, 2x times negative 2, negative 4x. Then we've got 3x and minus 6. And we just want to collect those like terms up. So the area is 2x squared minus x minus 6. There we go. Achieved question has been completed. Side note, this is why things like, if that's x minus 3, x minus 3, that's why x squared minus 6x plus 9, that's why it's called a perfect square, because it's like its two factors are the same, so it's obviously a square. So that's where that comes from. Anyway, solve 3 to the x plus 1 equals 81. We can't solve these exponent powers until year 12 with logs. However, these ones in the MCAT are usually quite simple. We just need the base numbers to be the same. So 3 to the x plus 1 has to be 3 to the power of some number that gives 81. You can just check that out. 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3 is 27, and 3 to the 4 is 81. So we want that to be 3 to the 4. Now that the bases are the same, we can just equate powers. So x plus 1 equals 4, x is 3. And just because it's getting quite messy, I'll just put a red box around my answers. So x is 3. Alright, it's not bad, this MCAT so far. Alright, we're solving this quadratic. Now, we do not have a common factor that we can divide out by, so I'm going to have to go first term times last term, negative 24. And I want factors of negative 24 that are going to make 2 when I add them together. So 6 and negative 4. That's my split. So I split that into 6x minus 4x minus 8. And I factorize each half. So I've just made that 2x, 6x minus 4x. Now I can factor this half out. 3x. X plus 2, and I can take a minus 4 out of both of those. Alright, notice, I'll slow this a little bit down. Notice that the x plus 2 is in both those terms. So you can just imagine that I'm going to factorize out all that stuff that's been highlighted. X plus 2, which would leave 3x minus 4 in brackets. That's our quadratic factored, and our solutions are negative 2 and positive 4 over 3. Cool. And that would be a merit question. So achieved, merit. Okay. This is probably going to be your excellence question, because there's a diagram. The area of this triangle is 35 meters squared. So area is half base times height. So half the base, 4x plus 6. That has to be in brackets because we're multiplying by the entire thing. Times by height, x is equal to 35. Now, I could put that half, I could multiply all of this by a half, or I could times both sides by 2. I think in a previous video times by 2, so on this video I might put that half in. So we're going to get 4x times x, 4x squared, times a half, 2x squared, plus 6 times x, which is 6x times a half, 3x, equals 35. Subtract that 35, 2x squared plus 3x minus 35 equals 0, and we have to solve this. So, is there a common factor? 2, 3, and negative 35 do not have a common factor, so I'm going to have to multiply the first and last term again, negative 70. Factors are negative 70, they'll split the 3, positive 10, negative 7. So 2x squared plus 10x minus 7x minus 35 equals 0. I can now factorise this side, 2x, and this side can have a negative 7 come out. There's one bracket, and there's my other bracket, 2x minus 7. So, obviously got two solutions, x equals negative 5, x equals 7 over 2. However, you can't have a negative length, so your solution is 7 over 2, or 3.5 centimetres. 3.5 metres for the context of this problem. I said I was putting a red box around my final answers. Okay, so we've had two of those more complicated quadratics to solve already. So it's obviously a key skill you're going to be wanting to take into this year's MCAT. Now I've really shortened this problem right down. So apparently Sophia and Tama's grandmother or mum is a maths teacher, and they are going to be given some fidget spinners. Sophia's going to get her number of fidget spinners is going to be based on n cubed plus 3n. Tama's is going to be 2n squared plus 6n. And we want to find for what values of n would result in Tama getting more fidget spinners. He wants more of them. So we want Tama 2n squared plus 6n to get more than Sophia. And it's strictly greater than Sophia's amount, not greater than or equal to, because he wants to have more. So we can set up this equation. Now notice that every single value has an n in it. So we'll divide out by n. So we're actually going to get 2n plus 6 greater than n squared plus 3. And just like solving quadratics, inequalities we want to be 0. So 0 is greater than n squared. I'm going to subtract the 2n, and I'm going to subtract the 6. So maybe pause the video, make sure that I've done that correctly. And then just like solving, inequalities we want factored n minus 3, n plus 1. Those multiply to negative 3 and add to negative 2. So I'm pretty happy with that. Now, I just like to think of these as parabolas. So obviously there's a positive in front of n squared. So it's this way up. And our two roots are negative 1 and 3. So basically the number n must be less than 3, greater than negative 1. In the context of this problem, you can't have a negative, and it can't be 0 either, because 0, because back here in the original, you've got 0 greater than 0, so that's not going to work. So n must be 1 or 2. If that number that their grandmother or mother, whoever it is thinking of, is 1 or 2, then Tama will in fact get more fidget spinners. You might want to just go through that one again. It's a little bit tricky. Right, that's question 1 done. Question 2. Straight into a rearrangement for R. So we know that to get rid of 9 over 4, we multiply both sides by the reciprocal. Okay, so we're going to times both sides by 4 over 9. Because then those 9's cancel and those 4's cancel. So R squared is 4 over 9 a. Then we want to square root both sides. R is square root of a, 2/3 square root of a, because you know that you can square root a fraction. You can square the numerator and square root the numerator and square root the denominator, and then we can't square root a, so we just leave it as root a. Also know that that is also plus or minus, because when you square root, you get two solutions, the positive and the negative number. Okay, this looks like a merit problem because it's all linear, but it's in a context. So we know the perimeter of this house shape is 32x minus 7. We want to figure out what AB is. We want to figure out what this length is. So we know if we take the perimeter, 32x minus 7, and we subtract these four sides, we'll be left with AB. So let's subtract 10x plus 1. That's take away 10x, take away 1, take away 6x, take away 5, take away 8x, take away 3, and take away 4x, and be careful here, take away negative 2. So that's plus 2. And that's going to give us AB. So now we just got to do a big collection of like terms. 32 minus 10 is 22, minus 6, or 16, minus 8, 8, minus 4, 4, 4x. Now the numbers, negative 7, take away 1, it's negative 8, take away 5, negative 13, take away 3, negative 16, and plus 2, negative 14. So AB is 4x minus 14. Easy. Just a lot of like terms to count up. But notice how carefully I did that. I don't want to do this great thinking and processing and then lose marks because I rushed my number. Now this video is probably going to be between 20 and 30 minutes long, so you've got heaps of time in the MCAT to get these questions done, even with me stopping and rambling. So we want to write this as a single fraction. So let's just look at something like a third plus a quarter. We want the denominators to be the same. So for something like this, you would just go 12. You go 4 over 12 plus 3 over 12, right? Because twelfths in terms of thirds in terms of twelfths is 4 twelfths, and a quarter is 3 twelfths. So in terms of algebra though, the lowest common multiple is always going to be the multiplication of these denominators. So we're going to have x plus 1 times x minus 2 be the common denominator, which means I have to multiply this 2 by the x minus 2. And I have to add 3 times this denominator, x plus 1, because you can't scale them up. You can't scale the denominators up and not scale the numerators. Now I'm just going to expand and simplify the top. I have 2x minus 4 plus 3x plus 3 all over x plus 1, x minus 2. And now I just got to collect my like terms. So you can see there I've got 5x minus 1. And that's still being divided by x plus 1 and x minus 2. Awesome. Okay. These inequality problems always get me, but let's see how we go. I need the base numbers to be the same. However, 20 is not going to get me the same base as 2. So let's just focus on this side for now. 8 is 2 cubed, and we've got 2 to the x minus 4 less than 20. Okay, we want this less than 20. Now, let's just tidy up this side. When we've got the same base, we multiply. We can add our powers. So it's just x minus 1 less than 20. What I do is I just take a moment, I think, I have to be less than 20, which means because x is a whole number in this situation, that means I'm allowed to be equal to 16, aren't I? So I can actually be less than or equal to 16. I have to be less than 20, which means I'm allowed to be equal to 16. So I've just changed the problem a little bit. Now, 2 to the x minus 1, less than or equal to 16. Well, 16 is 2 to the 4. Now, I've got my base numbers the same. I can just do the same problem with the powers. So x is less than or equal to 5. If you've got x is strictly less than 6, that's okay as well. You're not allowed to be equal to 6, but you can be 5 in this case. These are very similar when x is a whole number. So let's simplify this side out. Get the bases the same, reduce to one base power, and then less than 16. And let's just stop for a second. If this was around the other way, well then I would be going greater than or equal to the power of 2 that's above 20. So I'd be going to 32, and then I'd be able to solve very similarly. So that's how I do those ones. All right, this is a pretty serious simultaneous equation. So George and Leo organising 27 people into 2 groups. So there's students and adults, and there's a George group and a Leo group. So half of George's group are students, and 2/3 of Leo's group are students. The cost of the tickets for 27 people is $650. How many students are in Leo's group? All right. There's a lot of information there. Let's just find out how many students and adults there are. So students plus adults is 27, and there's a total cost of $650. I get $650 when each student pays 20, so 20 times the number of students plus 30 times the number of adults. Okay, what I'm going to do is I'm going to divide this out by 10, because there's zeros on all of those. It's going to be a bit simpler to write 2s plus 3a is 65, and I'm going to scale this one up by 2. 2s plus 2a equals 54. Now when I take this equation and I subtract this one, I'm left with just a, because 2s minus 2s is 0. 3a minus 2a is 1a. And 65 minus 54 is 11. So there's 11 adults, and that means that the students are 16 students. Well, that's good. Now I know how many adults and how many students there are. Okay. Next, half of George's group of students and 2/3 of Leo's group are students. So a half of G's group plus 2/3 of L's group are 16, which means a half of G's group plus 1/3 of Leo's group is the adults, which is 11. So straight away I can do this first equation minus the second equation, because a half of G minus a half of G is no G's, gone, and 2/3 of L minus 1/3 of L gives me 1/3 of L, which is 5. So Leo's group, when we multiply by 3, is 15. But 2/3 of his group, 2/3 are students. So there's 10 students in Leo's group. That's a pretty complicated simultaneous equation problem, right? You're looking at doing 2 simultaneous equations. You're going to want to rewind, follow that one through again if you didn't quite understand it. Okay, we're on to question 3. Right, a classic substitution problem. Okay, the area of a garden is given by an equation. find the area when x is 5 and y is 2. So we're just going to put 5 in. So the area is 2 times 5 plus 3 times 5 times 2 squared, 4. So 2 times 5 plus, because you've got to do your order of operations, 3 times 5 times 4. 3 5s are 15 times 4 is 60. So we've got 2 times 65, 130. Don't believe there's units in this question, so just 130 is fine. Now, simplify 3x squared plus 12x over x squared minus 16. There's a difference of 2 squares underneath there, so I know that's going to be x minus 4, x plus 4, and I can factorise a 3 and an x out of the top. I've got the same thing divided by itself, so that's just 1. Fully simplified is 3x over x minus 4, and I forgot I was going to put a red box around my answers, wasn't I? Alright, it's probably a merit question and an achieved question. Alright, yeah, I drew my circles really big because the only thing I have to draw circles in lockdown is a paper clip, so I can only draw this size circle or this size circle. But it's actually worked out quite well because that is nearly the 20 centimeter problem, so it's almost actual size. Alright, show the total circumference of the circle is always 20 pi centimeters. Okay, well, the circumference of a circle, if this is r, then what would the radius of this one be? Now, 2r plus, let's call this capital R and little r, plus 2r equals 20. Alright, so this radius plus this radius plus this radius plus this radius is the total height of 20. So 2 lots of this small radius plus 2 lots of this big radius is 20, or r plus r is 10. Now the circumference of the big circle is 2 pi r, and the circumference of the little circle is 2 pi little r. So the total circumference is 2 pi r plus 2 pi r. 2 pi can come out the front. This might be a wee bit of a complicated way of doing it, but we know that r plus r is 10. So 2 pi times 10, 20 pi. So the total perimeter, so total circumference of these circles, no matter how big or small they change, as long as their maximum height is 20, is always going to be 20 pi. That's quite cool. Okay, I believe that's actually an excellence question, just getting that. And so is the next part, I believe. So what's the difference in areas? Well, difference in areas is, I'm going to use little r again for the small circle and big R for the big circle, is pi r squared minus r. Big circle first, obviously. Pi r squared minus pi little r squared. That is the difference in areas. But we do know from here, I'll highlight it, we do know that r plus r is 10, always. So that means that r minus 10 is big R. So we could do that as a replacement. So we could go pi times r minus 10 squared minus pi r squared. It's because that's big R. So r minus 10 all squared is big R. So expanding this, we have pi r squared minus 20 pi r plus 100 pi, and we're still going to take away pi r squared. Pi r squared minus pi r squared is gone. We have got 100 pi minus 20 pi r. Yeah. And that is the difference in area. And some people want to factorize 20 pi out, and that's fine. 20 pi, that's going to be 5 minus r. So that is the difference in areas. I think that might be different to the example answers, because they use a little r on the big circle, which I don't really think makes a lot of sense. So they might have that around the other way if they've done it that way. But it's been a while since I've done the 2018 paper. All right, I think this is the last question. Yep, last one. So this MCAT's really ended on some pretty big questions actually. So we want the base numbers to be the same. So we've got 5 to the 1 times 5 to the 3x equals 5 to the negative 2x squared. So when the bases are the same, we can add powers. 5 to the 3x plus 1 equals 5 to the negative 2x squared. So not much work to get a single base on each side. Now the powers can be equated. Now that the bases are the same, that would mean that the powers would have to be the same if it was equal. We'll add the 2x squared. And then you just have to factorize and solve this. So first times last, since there's no common factor. 2 factors of 2 that add to 3, 1 and 2. So 2x squared plus 2x plus x plus 1. Split. Factor 2x of that side. And what can you always factorize out? A 1. And I don't usually write it, but it makes it obvious here. 1 bracket x plus 1, 1 bracket 2x plus 1. So your solutions are negative 1 or negative 1 over 2, negative a half. So, I mean, not much work for an excellence question. That's pretty nice. If you're wanting to be clever, you notice that 2 and 3 are primes, so you know that it's going to have to be a 2x at the start of that bracket. And then multiply to 1s, you know there's going to be a 1 both there and there, and it's all positive. So you know that's just be positive, positive. So it has to be 2x times x to get that squared. And there's a 1 there, so they have to both have a 1 as the constants in that bracket. You should still get full marks going straight from that to there. You don't have to show this process, but that's a reliable way of solving that quadratic. Nice, that is the 2018 day 1. Now you should probably go and attempt the 2018 day 2 and then check your answers on the ZQA website, because they'll be really similar. They'll probably do a question like this, but it might be 4 times, 4 to the 5x equals 4 to the negative 2x squared or something like that. They'll just change the numbers around slightly, but now hopefully you have the skills to give that a go. Awesome work.